I'm Jason Porter. It's my understanding that we'll be here together in this room for the next 75 minutes, and that we're talking about the Java Persistence API. Is that everyone else's understanding? Yeah. All right, good. Oh, and it's a reactive crowd. Very good. So much better than having the crowd that you hear the pin drop. Not good. All right. So I'm going to be talking about the Java Persistence API. I have some slides. I'm going to be going into code as well. And hopefully we'll do some interactive stuff, depending on the time allotment. So without any further ado, unless someone has questions right at the front. Actually, I should say, if you have a question, feel free to ask. There is a mic over here in the middle. If I don't happen to see a hand or whatnot, come up to the middle, use the mic. Feel free to ask when you have questions. I would much prefer to take questions during as opposed to after for a couple of reasons. One, because we may run out of time, and two, because you might forget your question if we ask at the end. So if you have questions, please feel free to start. And of course, I spent too much time with stuff and didn't fully get ready. So if I can find my remote, maybe. Awesome. Do I have remote? Maybe I have remote. Maybe I left it in the hotel room. I do have it. Very good. There we go. All right. Again, my name is Jason Porter. I work for Red Hat. Among other things, I've worked on the CDI specification. I'm on the mailing list for Java Persistence. I have started some conversations. I don't work on the spec, nor do I work on Hibernate, but I have been using JPA for quite some time. Among other things, I'm currently working on the jbus.org website, and I've contributed to Arquillian, Forge, Apache Delta Spike, and a couple other things here and there. So the first thing to know about the JPA is that it's exceptionally flexible. And with that flexibility comes a degree of complexity as well, because it strives to be able to allow you to do all of the things that you can in the relational database. Things get complicated, or there's more than one way to do things, as we'll see in one of the other things. But it is exceptionally verbose in some places and difficult. If you were to look at the spec is approximately 530 pages, so it's definitely not a light read. But we will do our best to kind of cover that 80%, 75%, something like that in this presentation. I have a schema today that we're going to be using and looking at. It's somewhat contrived. Thank the people from DB Answers for the basic schema. I enhanced it a little bit. So the idea that we have here is a library that has books. Books have authors and categories. Members belong to a library, essentially. They have addresses. Libraries have addresses. So not overly complex, but enough complexity and relationships to actually get an idea as to what we're doing. And this is going to drive me crazy, but that's okay. So that's that. Are we all good? Any questions so far? Okay. Very good. All right, the first thing about JPA, which is the core, is obviously entities. And entities, for the most part, map one-to-one from tables to classes, classes to tables. So what we've got, and we'll take a look at the code. Now, I'm running this in IntelliJ. So this is our book class, and we'll dive into some stuff as well. So I'm going to be going back and forth between IntelliJ and slides as well. So the basic mapping is really actually pretty simple. Everything in java.lang, so integers, shorts, characters, strings, dates, timestamps, from the SQL package. Those all map, one-to-one from the database to the entities, from the entities to the database. Not that bad. And you can do that without annotations or without the XML, specifying exactly what it is. However, you can do some overriding. And the first thing is this basic annotation. Now, before I get too much into annotations, if you're one of those people that likes doing everything in XML, or for whatever reason you have to do it in XML, everything that I talk about here can also be done in XML, but I'm using annotations so that you can do the XML stuff. So basic is there, really all it gives you is this fetch type and then column as well, which we'll dive in and take a look. Okay, so we have our book example right here. Now the first thing that says this is an entity is obviously the entity annotation right there, which tells JPA that this maps up to a table. Now the convention for JPA, it kind of followed that convention over configuration kind of deal, if it works for you. Table names are the lowercase version of the class name. So I could have gone without that. This schema that I'm using Postgres, so you can actually see how schemas work and whatnot. I'm just in the public schema in Postgres. You could use whatever. And then you can also have things like unique constraints. If you want to, you can define pretty much everything in your database in JPA as well. I don't know why you'd want to, but you can. If you want to get that closer to one, I'll stop stepping there, that one-to-one mapping between your tables and your databases or your entities, you can do that. So this one here, we've got a unique constraint. This should make sense. A book has an ISBN. ISBNs are unique, right? Not all that surprising. We'll talk about name query later and some of this other stuff. But the basic mapping and IDs I'll get to later as well. So the ISBN is simply where are we at? We're down here. String. Column I'm using, this works just fine. In some of these other ones, we'll take a look at. It may not. Oh, so down here, if you can see it. So the publication date. In the database, I have an underscore in between publication and date. In the Java, no underscore, capital date. So I'm saying that it's not exactly the same, so I need to tell JPA that things are a little bit different. And it's okay, just map things up the way that I tell you to. Also on a column, actually, let's just do this one. Yes. So on a column, yeah, that one, thank you. On a column, you have a name, which is the column in the database. Again, if you really want to, you can define your column definition. If you're starting from, say you're starting from entities and you want it to generate the database, if your DBAs even allow that, that's possible. You can tell it whether or not this column is insertable or not. You can give it lengths, tell it if the column is nullable. Precision and scale if you're doing floating point. Also the table that it's on, if for whatever reason your entity maps or pulls things from different tables, you can do that as well. Updatable, is that all of them? That's all of them. So that's all from column. Say if things are nullable. So for example, I'm saying you can't have a book that doesn't have a title, you can't have a book that does not have an ISBN, and you cannot have a book that does not have a publication date. Does that all make sense? Are we good? Cool. All right. Access types. This is something that changed in JPA 2. In JPA 1, then all of there are two places that you can put your annotations. You can put your annotations up here on the fields, or if you would rather, you can put them on the getters. No, that one. Depend solely a personal preference. There's a little bit of overhead, getting all the reflection stuff to map up and actually call the field itself, but you end up doing reflection anyway to get the method. So it's really next to non-existent. But you can put them either places. For me personally, I prefer to have them on the fields because I can look, I've already got annotations up here at the class. Typically, your fields are right up there next to the class, so I can look at the entity without having to scroll through and look for annotations all over the place. But you can, starting again with JPA 2.0, if you would like, you can do this. And it solely has a value, which you can admit or omit, and just say access is field type or property type. And that defines it for that entity hierarchy. This is one of those tips. Pick something and stick with it. Hopefully for the whole project. If not, then at least for that entity hierarchy. So if I had a subclass or a superclass of book, and I started my annotations at the field, or I had an access at said field, my JPA implementation is going to be looking for all of my annotations in that hierarchy at that location. If they are not there, things will not work. And I ran into this a few years ago with Hibernate, where we had them in different locations and things just blew up. Like it didn't even run. It went to deploy and stuff happened. It was not fun. So keep those all in one place. Again, find a style that works for you, for your group, and stick with it. Life will be much easier. I did mention implementations. There are 3 main implementations and at least one other that I know of, although the name escapes me. There is the Eclipse Link, which used to be called TopLink from Oracle. That is the reference implementation. There is Hibernate from Red Hat, which pretty much predates most of this stuff anyway. And then there is also OpenJPA from the Apache people. And that's used in Tommy, in where else is that used? I'm drawing a blank. Pretty much in any of the other Apache projects that use JPA. That's that one. And like I said, there is one other one, but the name escapes me. So you're going to be using one of those 3. Typically, unless you have a reason to use one or the other, you're going to be using what your container provides for you. And I don't have anything that is specific to one implementation or another, so this stuff should, right, all work in any of the other implementations. We talked about property access, did talk about portability, and with property access, so if you do annotate your getters, make very sure that any logic that you have in those is either 1, very quick, or 2, non-existent, because they will be called if you annotate your accessors. And that could also lead to exceptions if you're referencing data that has not been fetched yet. So if you're referencing things that are lazily loaded, that we'll talk about later, then things will blow up if it is in the logic in those getters and you're annotating the getters. So make sure that you have that in the way that you would like. Transient. All right, we will be here on the book. So now we get to do some of the fun stuff and do interactive things. Okay, I need something from you all that is a property of a book, but that I may not want to store in the database. Wait, sure, we will go with that. Private type. Float. Wait. Okay, we come over here, say transient, there we go, and that's it. It doesn't take anything else. And what that does is that tells JPA that this variable, this property field, just ignore it. It doesn't need to be persisted to the database. Don't worry about it. So there's not a whole lot there, but if you do have some of these things you don't want persisted to the database, make sure that you use that, especially if you are using property annotations and you have other properties that start with get that may not actually reference fields. Make sure to annotate those as well. Alrighty, now we get into some fun things. Primary keys and IDs, and then also composite IDs. And composite IDs are where things get really kind of funky based on how you want to do them. So back here at the book, simple keys are really very easy. So we have an ID, and you mark it with the ID annotation. And that's really all that you have to do. What we have going on here, again, I said this is Postgres, so you can tell it the sequence generator that you're going to use. It can reference something from the database. It can, well, let's take a look at it. A sequence generator has a name, an allocation size, so basically how much, if you're talking to code or the database, go fetch a block of X, right? And then just keep using that so you're not hitting the database every single time. Also a catalog, the initial value schema, and a sequence name if you need to do any of that. There is also this annotation, generated value, and the table generator. The table generator, what that does is you can have another table in the database that does nothing but store IDs. And it goes and it fetches a new one, increments it, puts it back in the table. You can do that as well. Or you can have a sequence generator that actually is some code that you have running in Java that you go talk to that and it generates the next ID for you. You can do that as well. Now you'll notice in this one, I'm using the object as opposed to the primitive long. And that, you can do either one. I have personally found that long, the object or integer, depending on how often you plan on writing to this thing, works better than the primitives for one simple reason. When you're creating them, now I may have, in this example, I may have a book that I create that for all purposes, except for the ID, is the exact same book as what I already have in the database. But if I use the primitive, then it starts at 0, right? And that may or may not make a difference in your logic. But if it's null, then I know for sure that it hasn't touched the database at all. I prefer to use the object versions. Again, that's a style thing. Yeah?
Can you also use UUIDs instead of the long for that?
You would have to store that as a string in the database or something, and you would also need a converter, which we'll talk about later, because that is not one of those objects that it will use. The question, I'm sorry, need to get in the habit of this. The question was if we could use UUIDs for IDs in classes. So short answer, yes, with some caveats. Let's see, ID, Any other questions about simple IDs? Okay. Composite keys, again, is where things get complicated because there's 3 ways, according to the spec, that you can do this. And the embeddable ID is how I have one that we'll take a look at. And we'll actually, might as well go look at that now. In here, yes. Was this it? Yes, this is part of it. We have, if you remember back at the schema, should I pull that up? Would you like to see the schema one more time, real quick? Okay. Okay, so in our schema, we are looking at this one right here. Now this looks like, according to this anyway, it looks like a basic many-to-many relationship, right? But I have some extra data here in this table. Now the way that JPA says you have to do that is we have to model this entity itself and then create IDs and composite IDs that map up to things. That's what we're doing here. So we have the foreign key book ID, the foreign key library ID, and then we also have this quantity. Now I am saying that this library or book at library ID is an embeddable class. It doesn't have the entity on it at all, but it is embeddable. And then we go over here to book at library. Go away. Over here. Maybe. Thank you. And then we have the embedded ID right here. And we're saying at the entity, scroll up a little bit, this is an entity with a table, all the stuff that we saw at book. And we're referencing the embedded ID at the type right here, and then we're overriding some of these things. So we're saying quantity, we've got our definition over here, library and book ID. Over at the columns are, they're down here. Sorry, my bad. So these columns, so we've mapped this up in a couple of places, right? We've got a book ID and we've got a library ID in the book at library ID class. And we are saying here and here that we don't want you to update or insert from this class. That'll be done in that embedded ID right there. So this is one of those ways of doing complex keys. And they do get complex and a little bit difficult sometimes. We went through that one. Another way of doing it is to use the ID class. What we do on that one, if we were to do it this way, we'd come up here to the top of our class. Wow. And we would do ID class, and that just has a value, takes the class. You put the class reference there, and then you add the private, class ID, whatever there, and that's how you do those ones. Oh, I want to go back here. And then there's also maps ID, and this one, to be perfectly honest, I have not ever used. But if you have a map and part of that has the ID in it, then you would have the maps ID there. You'd annotate the map, tell it which column or which key or value it is that actually maps up to the ID, and go from there. Okay, this one is another one of those tips. There is a difference between Java object identity and identity in the database. The database assumes that if the primary key is the same, it's the same object, right? Well, that may not necessarily be the case in Java. So one of those things you need to do, and let's go back to book. No, wrong thing. Book. So inside book, we've overridden, you might not see it down here, but I have hash code over here, and I have equals over here. Now, it may make sense for you to include that ID in your equals method, maybe not. I have in here, I could strip that out, if I were to go and comment this, although I am using it in hash codes, that may break that hash code equals contract that you have. But it is important to make sure that your objects are relying on things that make sense business-wise to say if your objects are identical or not. And one of the things, if you solely rely on the primary key, JPA will say they're different. But if I rely on objects, implementation of hash code and ID, then if you start putting these things in things like maps or other things that make use of hash code, things might break and you may not have the desired outcome. So always make sure that you're implementing equals and hash code the way that makes sense for your object. Questions so far? Are we good? Okay. Serializable. You will have seen in most of my classes, these ones are serializable. It is not required to be serializable, although if your class has the potential for traveling outside the VM, then you need to implement serializable. If you're going to be sending it through a REST service, through an RPC call, or just over some other transportation mechanism outside the VM, then you need to implement serializable. In these ones, I don't have the serial version ID, but good practice says yes, create those. So there is that. Now relationships, and this is one of those other cornerstones for JPA. Now inside your data theory, you have sets and bags and tuples, essentially, right? Inside JPA, a set maps to a set, which you would expect. A bag maps to a collection, which is oftentimes a list, although it doesn't have to be. And then tuples map to maps, which makes sense. So there is that. One of the things that I have found is that if you are going to be using lists, stick to collection, or at the absolute least, use list. Do not be programming to the implementation classes, because all of the JPA providers have their own implementations for list, for set, for some of these other things. So if you are programming, program to the interface. Otherwise, when it goes to set that, then you'll get a class cast exception, and trying to figure that out may be difficult. So program to the interface, and personally, I prefer collection. That way, whatever it is that the JPA implementation sends my way, I know I'm going to be able to work with that. And I can cast it or create new lists or whatever fairly easily with that. The other thing to note with collections or lists is that you are not guaranteed list order. You're not guaranteed that from the database. You're not guaranteed that from the JPA implementation. And you're certainly not guaranteed that if you start mixing those things up. If you change databases or change implementations, those are not guaranteed. Caveat, unless you use an order by, right? So if I do the order by, then of course it's going to come back the way that I expect it to. Also, portability, which I did mention with the lists and maps, those things. JPA has this idea of bidirectional and unidirectional relationships. And what we have in code in almost all of these, I believe I have one in book. Nope, but we can create one. I know I have one in address. Actually, I believe I have both in address. Okay, so we have members, which if you remember at the schema has, it looks like it's a many-to-many. I'm saying for purposes of this presentation that it's a one-to-many. So many members can have an address, right? I'm assuming that you're going to give me one address, you're going to give me a home address or a work address, but not give me both, right? That was something I did for this one. But members, if we go look at members, it has the inverse of the relationship. There it is. Now this one, when you're dealing with bidirectional ones, there are a couple of things to make sure that you get right. The first one is what the spec calls the owning side of the relationship. Now the owning side of the relationship at the table level is the one that the table that contains the foreign key is the owning side of the relationship. In the entities, it has that join column right there. And then on the inverse side, if we go back to address, where are we? Down here. Can you still see that okay? Okay. On this side, you'll notice we have no join column, but we do have mapped by. And what this points to is that field or that property on the other side of the relationship that has the many to one or the other side of the relationship. So you have to make sure that those are right, otherwise things won't work right. The other trick with bidirectional ones, and I will just add this right here. So we will do public void add member, takes a member, m, and we will say this dot members dot add member, whoops, and then member dot set address this. When you are dealing with bidirectional relationships, you have to make sure to set both sides of the relationship, otherwise it will not persist. That's another big first time annoyance or pitfall that some people fall into. So make sure you have those where you're setting both sides of the relationship if you are doing bidirectional. And oftentimes you will see this kind of pattern where either at a higher level, at like a DAO or something like that, you actually add things to one side or the other, and then you make sure to set at the other side as well. If you are doing a unidirectional, which I have one somewhere, I don't remember off the top of my head, but I do have one, you don't have to worry about that. You set it on the side, the owning side, and then you're good to go. Let's see, bidirectional, unidirectional, yep. Yes. The kinds of relationships that we can create in JPA are one-to-many, many-to-one, many-to-many, and then also one-to-one. If you looked up above, we have a one-to-one on library. Again, for this purpose, I'm assuming that a library only has one address, which seemed like a fairly reasonable assumption on my part. And no other library is going to have that address. So that made sense to me to do the one-to-one. Do I want to talk about that? We will get to the fetch types. It's in the slide, so I think I'll wait for that. So there is one-to-ones. I believe I have the Bookit library. Nope. Bookit library I also mapped up as a one-to-many, many-to-one. It's many-to-manys are exactly the same thing. It's just many-to-many instead of many-to-one. Everything else is the same. You can, yes. So if I did not have the quantity on this one, then I could have done without the extra object, and then you can do join table as well as column. So you can tell it the join table. In this case, if we didn't have like the books and author ones can go this way. You can tell it the table that it needs to go to, and then also the column as well. Questions thus far? I haven't put anyone to sleep, so I think I'm doing well. Eager and lazy. I did say I would get to that. So this idea for relationships, and again, if you remember back, if you use the basic annotation, you can also set these on other fields. What this is saying is that when you go and retrieve this entity from the database, if it's lazy, don't bother retrieving the relationship right now. You go do that when I reference it the first time. If, however, I switch this to eager, then that's going to perform the join as soon as it goes and fetches that. So it'll all come back in one SQL statement, right? I'll select star or whatever, join table, blah, and it'll pull it all back in, create the objects for me that way. That is one of those things when you start looking at the performance of your JPA application. If you need to make that trade-off between joining now or joining later, I can't say which works best for your application, but that's one of those things to look at, as to when we're going and talking to the database versus now or when I actually need it. And it does play a role in detached entities, which we'll talk about later. Cascading. I do have cascading. Where do I have cascading? It's at the library class, I believe. Libraries, yep. Okay, this is, you can't see it, but this is that library and address relationship that I have here. Now I have a cascade right over here, and then this takes an array of cascade types. Or if you want everything, then you can say all. Now the various cascade types here are remove, all, detach, merge, persist, and refresh. These are the operations that the entity manager performs on the entities. And if I want to cascade those to the relationship, so if I persist something and then I also have the relationships, I can cascade that persist to those other objects as well, or deletes, merges, all of that kind of thing. This is one of those areas that throws people off, and the best thing that I can say is read something, whether it's a spec or a book or something. Make sure you understand this, because it can play difficulties with how things work based on what you're talking to, when you're talking to it, and what you're sending to the database. Make sure you understand cascade types and how they affect things. For this one, I am saying that when I persist a new library, go ahead and persist the address as well, and when I remove it, so when I delete it from the database, go ahead and delete that address as well. And then the other one, which I'm pretty sure, let me verify, is the next slide, yes, is orphan removal. Orphan removal showed up in JPA 2.0, and what that does is in this one specifically, if I no longer have if I no longer have a library, then I'm also assuming that I'm going to remove the address. And if I don't do that, then the address is floating out there and it no longer has the parent side of the relationship, so it's now an orphan. And you may care about that, maybe you don't. For this one, I'm going to say I don't want orphans in the database. So if the parent is removed, also remove the child. Toss that out there, I don't want it. Sorry, what? What's the order of things? Oh, what's the overhead of it? Thank you. That's a good question. I've not looked at the SQL. I would, just based on my experience, I would say that is an extra SQL statement that gets sent. Yeah, delete from library where ID equals, and delete from address where ID equals. That's my gut feeling, but I'm not 100% sure on that. And that may differ based on the implementation as well. You had one?
Yeah, so if you do persist and remove, why would you need that?
When would I need that? So if, when I need the cascades, right?
Well, no, you do the cascade, let's say you move a book,
Uh-huh.
a library,
Okay.
it'll automatically remove the address record as well.
Yes.
So then why would you need, how would it ever happen for orphan if you did that?
In this exceptionally contrived example, it wouldn't. All right, but there could be other ones where you're not cascading the operation. In that case, it definitely could happen.
It's kind of two different ways of doing the same thing?
It could have happened from outside, right? In the database.
Yes, it could happen from outside as well.
But then I don't ever see how you would ever see that condition.
When you come to that child record, when you come to that child record and you're doing something with it, then the parent will be, if it's orphan, then it'll take care of it at that point.
So
Yeah. All good? Perfect. All right. Any other questions that we've got? Okay.
Can you dynamically control the fetch type?
Can I dynamically control fetch type? From
Like if I have a library and I don't do a report on the books, I want to fetch the library. This time I want the books. The other time I may not want the books. Maybe I just want the address.
that, now programmatically, so the question again is, how can I control fetch types? At the JPA level, I get either eager or lazy, okay? Eager says go fetch it as soon as you fetch the parent object. Lazy says go fetch it as soon as I access it. So that's as close as you can get with JPA, is fetch it lazily, and the next time I access it, then go talk to the database and pull it back in. Okay. Other questions? Yes? Yes, default is lazy. Yes, the default for fetch types is lazy. Yeah. Okay, I don't see anything else. Talk about orphans. Oh, type converters. here we go. Okay, type converters, we have, and I actually have one, if you remember looking at the book. So I have a publication date, which I am saying is a temporal type. And the temporal types are one of three things. They can either be a date, a time, or a timestamp. And that's the timestamp that you all know and love from the Unix epic timestamp, right? Now, those things can be a Java util date, a Java SQL date, a Java SQL timestamp. I think that's it. There may be one other, but I think that's it. You'll notice that this is none of those. This is actually a Java 8 Java time local date. So what we've got here, and this changed in JPA 2.1. So what I have here is JPA 2.1 code. I have a converter here that is up here. Go away. And all this is I say a converter and then implements attribute converter right there. And it has two methods that you implement. Convert to database column, so that's going to take in what is on the entity and convert that to something that the database can read or that JPA can read natively. And then also the convert to entity attribute, so I get what the database sends to me and I convert it to what the object expects. Does that make sense? Okay, I'm seeing heads nod, so we're good. What changed in 2.1 is this part right here, auto apply. So what auto apply is saying in 2.1 is whenever you see the local date, assume that you're going to be using this converter. Before, what you had to do was go in and every single place that you had the type, you would have to use the converter local class. That's what you this is what you have to. We're down there. Let's go up a little bit. This is what you have to do in JPA 1.0 and 2.0. Every time you use one of these that JPA doesn't recognize natively, you have to add the convert annotation. And again, 2.1 auto apply true works everywhere. And I believe, let me verify that real quick. Default is, okay, so default is false on auto apply, which makes sense because otherwise that would break backwards compatibility, and that's a bad thing in Java, right? So if you want this to work that way, you have to explicitly set that to true. That's not going to go anywhere. Oh, it closed all of my files. That was nice. Thank you. Yes. Converters work for so that UUID example that we had. You'd end up doing the same kind of thing where you create the converter to go from the UUID to the string, from the string to the UUID. And again, that works for any kind of class, any class that you've created, any class from the library. As long as you can break it down into something that you can store inside the database, you could, I haven't done it, but at least the theory, you could even serialize your Java object and store that in the database in like a blob or something, and then bring it back. You could potentially do that as well. So anything that you can get down to store in the database, you can convert from one to the other. Does that make sense? We good? Okay. Type converters. Inheritance. Okay, inheritance is one. Now I've got half an hour left. I do not have an example of inheritance. And I'm going to leave that till the end. If we have time, we'll go through and do one. But the idea of inheritance is any of these types. Now we're back at the book. I can have either a superclass or a subclass that could or could not be an entity, and you can persist things that way. The two ways that JPA treats inheritance at the database level are through the table per entity. So for the example that I've got, if we have time, we'll go through and create this. So say I have an illustrated book or a book with illustrations that that has pictures. So we'd actually want to list things like figure numbers or something, or illustrators. I could say that illustrated book extends book, right? And then I've just got some other things. Now I can tell JPA if I want to do table per entity, which means I would have a book table and I'd also have an illustrated book table, or I can use the discriminator columns. So I could have it all in one book, and then I could have a column that says, B for book or I for illustrated book or something like that. Then you'd have some nulls there and whatnot. So whichever way you need to do your inheritance, you can make that work. You can also do inheritance, or sorry, you can have mapped classes as well. Mapped. So I can say a mapped superclass. If I have a mapped superclass that has fields that I care about in the database, but I don't want that superclass to be persisted to the database, I can basically tell it, I only want these fields, and this is in the superclass. So I annotate those fields and it'll persist those, but the superclass itself is not an entity. Is that all confusing as mud? Yes?
The superclass does not have the entity annotation, but does have the column annotation.
It may. Now you can go both ways. I can say yes, entity, no entity. Okay? Like I said at the beginning, it's flexible. You can do lots of different things to it. So I may have JPA annotations on a non-entity class that I want to include in a child class, or it may be a full-on entity that I want to include everything from. Does that make sense? Okay. Alrighty. That covers mapped class. If you're interested in what's here, oh yes, this would be what I would put at the mapped superclass. There is no. Guess not. Okay. Boop-a-doop-a-doop. That. I believe we're good. Talk about inheritance. Any questions before I move on to queries? Yes?
In your example, you talk about the different number of relationships there, but I do not see you leverage the foreign key. Is that the option you did not choose to do, or it's not something supported by the JPA?
Okay, question as in the relationships, I'm not referencing foreign keys. And I actually am. Let's find one. Yeah, that's totally fine. They're easy to miss. Let's look at, not a book. Let's go to an address. So an address no, address was not a good one. Library. So in the library, if we were to go back and look at the schema, a library has the foreign key to an address ID, and then we are doing it right there at that join column. So that's the foreign key in the library table that maps back to the address table. Okay. Other questions? All right. We will move on to queries. Queries is that pretty much that last cornerstone of JPA, and probably the thing that you'll be doing the most of, right? You map up your tables, your entities once, and you're pretty much done with it, right? However, you end up writing queries and talking to the database all the time. So there are lots of different kinds of queries in JPA, and all of them are interfaces. Now, the base type of every single query is query, and it supports all of your basic things. And then in JPA 2.0, we created, or they introduced typed query. And what that does, a query, when you go back and retrieve the results or the single result, it comes back as object, right? Because we're Java and we don't like reified generics. So in JPA 2.0, they figured, oh, well, you know what it is that you want. You tell us a class that you're expecting, and we'll do all the casting for you. So I can just say list of books, entity manager dot create query of type books, and then I can work with books instead of objects and have to cast. Very helpful, very useful. Although the regular query also comes into play where you don't want to type query sometimes. We'll talk about that. Named queries. Named queries, if you remember on the book, I have a named query annotation. Named queries am I in a book? I am not. Whoa, hello. I want to go to book. So up at the top, I have a named query annotation. And what this does is this tells JPA that this is now a registered query. Now it's important to note that just because it's a registered query, it is not a prepared statement on the database side. That's according to spec. Some implementations may actually make that a prepared statement, but that's not guaranteed by the spec. So I give a query. Could you do a prepared statement on top of this? I'm not sure. My gut tells me no, but I'm not 100% sure on that. But there is a way that you can do that kind of stuff that we'll take a look at. Yeah. Sure. Yeah. Yes. Yes. What this is, I give the named query a name, and that's how I'm going to refer to it in the code. And then I give the query. Now, this is the first time we're seeing this stuff, and I'm not going through all of the detail of this. This is called JPQL, and in a nutshell, it looks a lot like SQL, acts a lot like SQL. The big difference is that I can traverse the object graph inside JPL or JPQL, whereas I can't in SQL, right? So we've got a query, and we're also talk about it now since I'm here. You can do parameters to queries. So this is a named parameter. I could also do this, like you're used to seeing from JDBC or some other ones, where that's a positional parameter. You tell it what position you're placing things in, as opposed to the name.
Question about the JPQL.
Yes.
It looks very similar to HTML, right?
Yes.
Code base the same or related?
The idea very well may have come from Hibernate. If you are using Hibernate as your provider, then yes, it's exactly the same, and you can use HQL in place of JPQL.
In the name query, if you have, like in here, for example, if you select B from book, if you have basically some attributes that are defined as eager, does it respect that as well? Does it eagerly fetch everything else basically within book?
Yes, so the question is, if I have attributes on the object that I am selecting, if things are eager or lazy, does it respect that? The answer is yes. Yes, it does. Now there is this one. If you want to go through and actually eagerly fetch some of those lazily loaded things, you can do that in a query as well. So I'd say something like select B dot categories, which I don't have here. This is one of those exercises. If we get time, we'll go through and create one. So like a category, I'd say, is lazily fetched. But when I do this query, I want you to go fetch it anyway. And then you can also at the we'll take a look at this. Wrong key. Book DAO. Yeah. So we've got a type query over here. I can say find by ISBN dot set. No. Set. Where are you? No. Oh, that was flush mode. My bad. I'm sorry. Yes. Yeah. So you'd end up manually going and writing that JPQL like I did before, and then tell it to go fetch things and pull it back. Let's see. Actually, this works out well. So we have here in the entity manager, that's what EM is. EM is the entity manager, and we're going to create this named query, so that name that I gave it, and this is a typed query, so I say books, and then our type query, which is over that way, says type query of type books. And then we've got a parameter that we're setting over here, giving it the name, and then the type that we passed in right there. And then we come through here and say get single result. I'm expecting that there's only going to be one result, right? That ISBN is unique, so there should only be one. There are other options that you can do on a query. You can get the single result, set parameters. You can get a result list if you're expecting multiple things coming back. You can tell it. So we've got, where are we? Here we go. Who has to do pagination in their apps? This kind of stuff you can do with JPA as well. So I can say find all. So here's a query. Actually, that may not be fully correct. Create query, is that right? Name query, yep. Okay. Select distinct, blah, blah, blah. A lot of this was generated. But you can do that. And then I can say if I passed in a starting position and a max result up here, then I can say I want you to start at that point in the result set, and I want X number of results to come back. So I can continually fetch that query starting at that pagination number, 10, 20, whatever it may be, start there, and then give me the next batch that way, and call that over and over and paginate things that way. Questions so far on named queries? Yes?
Actually, back to the example you did ago where you had two parameters in the select. If you wanted to fetch that back, how would you get those back?
Okay. You can do what, do I want to go, well, let's see. So you can have JPA return back what it refers to as scalar types. So if I only want certain things from an object, and this is where I was talking about if you have a query and it gives you back objects, if I'm getting back scalars, then I can't tell it, it's going to be these three things, right? I'm going to get back a list of objects. So if I say I only want the books, maybe the page number, the weight, whatever, just give me those three things. You say select b.weight, b.page count, b.publication date from book B, where, whatever. And then I get back the result set. Those are not managed. It just gives me back those things from the database, and that'll come back as a list that I iterate over and do all of that stuff. Yes, you'll get a list of objects back that you'd have to go through and cast and whatnot. But yes, it is possible. Not seeing anything. Okay, we will move on. Native queries. So you can do native queries. You can do named native queries. You can pass it straight up SQL. And then you can also have those create managed entities as well, using this SQL result set mapping. So basically that would be, select table columns from where, whatever, result set, have it populate this class from the database, which is what JPA is doing anyway, but I'm saying I want to be in control of how you instantiate that, well, not how you instantiate, but what you instantiate with that and you can tell it to do things that way. And as we said before, it can return back managed or unmanaged objects or the full scalars. Now I know it will come up, so the can I do stored procedures with JPA? The answer is definitely yes, it can be done, and I don't have an example of it, so I will leave that to you to look at. But you can do the stored procedure query and actually set that. Now you were talking about prepared statements. You could do stored procedures that way. You could also prepare statements and then name them kind of the same way. You can do similar stuff with JPA.
Yeah, using the schema that was given, and then using the last week. And then using converted workers, and that's the way to request that.
Oh, okay.
So that's the path that I do.
Right. Right. Yeah, so you can do stored procedures, you can do prepared statements, all that kind of stuff. Yep. And the stored procedures, if you saw it while I was looking through the functions on the entity manager, you can create a stored procedure query, and that will allow you to add the stored procedures properties both in and out and both. So it supports that as well if you need to do any of that kind of stuff. There is that. Flush mode. Flush mode is set at the entity manager or at the query level, and if you set it at the query level, then it overrides for that query whatever is at the entity manager. Now the flush mode, first off, works at the transaction level, and what that says is that tells JPA when to go back and talk to the database. Auto is default, so you let it figure it out. Commit would be as soon as my transaction. Now, more often than not, unless you're managing transactions yourself, that's going to be a user transaction that is given to you from your container. So at the end of that transaction at the commit, then it will flush and kick everything out to the database. Other things like Hibernate, you can actually tell it to manually flush if you can get the session object and whatnot. So you can do that. But by default, it will figure out when it wants to talk to the database, which is usually at the end of the transaction. Questions? Nope. Okay. Parameters, I talked about parameters. The criteria API. I love the criteria API, as difficult and convoluted and verbose as it may be. It's actually very good. And the thing that I have found it's the best for is if I am having to programmatically build up queries, right? It's all nice and to say, here's my string and it's one line and it's really pretty, right? But the reality is that you have some method and you pass in 5 different things, and if this, add this to the query, else add this to the query, blah, all this kind of stuff, and your query ends up becoming the string builder that you build up things and you push it back, right? The criteria API gives you a type safe, and that's one of the cool things, it gives you a type safe way of doing that programmatically. But it is very verbose and it does get complicated. So I'm saying, especially since I have about 10 minutes left, it's out of scope for this talk. But the best place that I have found, believe it or not, to find information about the criteria API is the spec. The spec has a lot of examples. It walks it through very nicely. So that's my go-to place for information on the criteria API. Other people have written things about it. Other people have tried to simplify it. So you can find information out there, but I like going to the spec. Let's see if I can finish. Lifecycle. The lifecycle of an entity is a new instance, new book, blah, to a managed entity. That's where I say entity manager persist my new book. To a detached entity, where that may be it came in through a REST endpoint, or the transaction, the entity manager that it is associated with has since gone away and it's been garbage collected. Say I saved it in the session or something. It's gone away. It's now detached. It's not associated with an entity manager anymore. And you can reassociate it, we'll talk about that. Or a removed entity. So something that I have set entity manager.remove. So issue a delete statement on the database, but the entity itself has not been garbage collected yet. So that is also possible. Creation, new book, new whatever. Persisting entity manager.persist, send it the object. Am I still in, yes, I'm still in the DAO. So this one, em persist, new book, whatever, delete, remove, not that bad, right? Removal, talked about removal. Syncing. Now there are two ways that you can get an entity manager. If you are inside an application server, that you're just going to assume you give it to me with the persistence context, or maybe you're using CDI or something like that, then you don't have to worry about this, it's taken care of. If you are doing an application managed persistence manager, then you have to manually join a transaction. It doesn't talk to the database unless you're associated with a transaction. So you have to make sure that you join the transaction. Otherwise, your stuff won't go to the database. Yes, you can also say it's unsynchronized. Honestly, I have a really hard time coming up with a use case for it, but it is possible. Refreshing. If I have an entity that has been detached, or say I'm going through a wizard and you fill out something, then I send it back, I persist it, but I'm keeping that entity still around in, say, like a web scope or something that lives longer than a request. So the entity's still around, and I need to reassociate it with a new entity manager. Then you call entity manager.merge, and that reassociates it with this new entity manager. However, any data that you have on the entity that you pass to merge is overwritten with what's in the database. So if they don't match up, then your stuff is gone. So you'll want to make sure that you've got that. That also comes into play if you are doing optimistic locking. So if you have a version column and those version numbers are out of sync, then it'll throw an exception on that stuff as well. So you'll want to make sure that things match up before you persist. Otherwise, things don't work. Evicting. This is where if I want to manually remove it from the entity manager, not the database, but just detach the entity, I can do that. Make sure you're flushing entity manager.flush before you do that. Otherwise, you obviously lose any changes that happen and they don't get sent back to the database. Detaching. The key thing with detaching is right here. So if I have a detached entity and I happen to access a lazily fetched relationship or field that has not before been fetched, I get an exception because it's not associated with anything, it can't talk to the database, and there's nothing there. So instead of getting a null pointer exception, you get the, it's a persistence exception. I don't remember exactly what it is. So it is there. Depending on which camp you're in, all of the JPA exceptions are unchecked exceptions. So you don't have to catch them, but they may be something that you'll want to explicitly try and catch depending on your application logic. So there's that little caveat. I don't have much time. How many slides do I have left? Holy crap. Sorry, question, can I perform what? That is not defined in the spec. I can't run DDL by JPA by the spec. Some implementations will allow it. What you can do at JPA 2.0 is that you can tell it to create the schema, but oftentimes your DBAs won't let you do that, right? So running stuff through is not according to the spec, but some places may allow you to do that. And I have about 5 minutes, and I am running out of time. So we'll see if I can blow through this. You have callbacks that you can do. You have entity listeners that you can listen to the different events that happen. And these are really simple. You register an entity manager at pre or post operation, and then it sends you the entity, and you can listen to that. Locking. JPA supports pessimistic locking, so your row locks, your table locks, you can do all of that. And then also optimistic locking. If you can do optimistic locking, please do it. It will save you headache and grief later on. And what that is just a simple version annotation. You can use integers, shorts, longs, or timestamps on those. Those get incremented every time you update the row. Persistence contexts. Transaction is default, extended if you want your persistence manager to live longer than one transaction. Things get kind of complicated then, but you can do it. Packaging, almost done. Okay, so the persistence unit is a jar. You package up all of your persistence stuff, any of your annotated classes or whatnot, they go in that jar, and you need a persistence XML. They're short, they're not that bad. We'll take a look at one real quick. You can also add data sources. Data sources are not covered by JPA, that's a different spec, but obviously you need some way of talking to your database. And then you can also do a mapping file. If you don't want to do the annotations, you can do XML. Look at that later. Did that, okay, there we go. So the, you're not going to find it that way, are you? The persistence XML is really pretty easy. There's not a whole lot to it. So you have your persistence and then the schemas. So here's a 2.0, here's a 2.1. You have your persistence unit. The name, when you're actually getting the persistence unit, you use that name. You tell it if it's a JTA or non-JTA transaction type. Tell it the data source. Now the listed or unlisted classes, you can tell JPA that I want you to only consider the classes that I have mapped up here in this file, or you go find all of them that are annotated and use those. So you can go either way with that. And then any properties that you're sending to the implementation itself, these ones are all Hibernate. You can do OpenJPA, TopLink, Eclipse Link, all of those kinds of things. And then you end, again, there's not a whole lot there, but that is required if you want your implementation to actually pick those up and do that. I believe I am out of material, and I'm also just about out of time. So if you're interested in this highly contrived example and want to look at it, you can find it up at my GitHub. It's up there now. It obviously doesn't have any of the things that we've just talked about or I've added, but you can take a look at that as well. It also has some testing as well that I was not quite able to get to work yesterday, but you can test these things as well, and it's all up there. I have, let me ask my, my aide. I'm just about out of time, right? Yes, okay. I'm going to take a couple of questions if people have them. Yes?
Pros and cons of mapping versus annotation.
Slight overhead at deployment to find them if you're using annotations, but you're going to be scanning for annotations anyway. The mapping being in the same place with the code versus externally in the XML file. Those are really all that it is. Yes, yes, you get the same result. Any other questions? Yes. No, Spring Data is not an implementation of JPA. Yeah, it would be a competitor. Other questions? Nope, we're good. All right, everyone, thank you for attending. And enjoy the rest of Devoxx.